Let's move on to a very important and interesting concept in Python programming, which is known as broadcasting. Now, broadcasting is a powerful mechanism that allows the NumPy to work with arrays of different shapes when performing arithmetic operations. And what you can do is you sometimes might face a situation you may have a larger array and then you need to add a smaller array to that larger array. Okay, and in many cases that addition of smaller array or doing operations on a smaller array along with the larger array is meaningful, is mathematically useful and meaningful. Then Python allows you to do that. One of the simplest example is, let's say if you have a matrix, right, which has like n number, n cross m matrix, which has n cross m elements that you have, and if you want to add a single number to each of those elements, right, then you can just do define a matrix and you can add a number, and Python will automatically add that number to element wise matrix that is there. And this is the simplest form of broadcasting, but I have taken a different example of broadcasting here, which allows you to add a vector to a given matrix. So what I have done here in this example is I have initialized one essentially array x, which is essentially a matrix, and then v, which is essentially a vector. And what I want to do is I want to add the vector v to each row of the matrix x that is out there. So I want to take 1 0 1 and I add that to 1 2 3, which is the first row, add that to the second row, which is 4 5 6, and so on. So I will take each row of the x matrix, and to each row element wise I will try to add 1 0 1. So if I execute this command, right, I've initialized this vectors and now we have adding, you can see that 1 0 1 has been added to each rows of the array x or the matrix x that we have defined up. So this is an example of broadcasting, and again in deep learning class going forward we will be discussing some example of how to use broadcasting, which is very useful in deep learning applications going forward. Let's move on and discuss one of the very useful libraries that can be used to handle data structure and do some data analysis. And that library in Python is known as Pandas. And Panda is an open source library that allows you to handle different types of data structure and do some basic data analysis. So let's go through an example problem. As we discussed previously, right, whenever you are using a library, first thing that you need to do is you need to import that library. So you essentially, here we are importing Panda as a PD, and now we can use PD throughout our command, and we can use different commands and different functions that are there in the library for ease of use. So after importing Pandas, what we are doing here is we are essentially importing a CSV file. So I have stored this CSV file in the same folder in my Google Colab, and then I'm importing this CSV file, which is like a comma separated version file, which is a text file to store data, and it's a simple file, and it is used in many spreadsheet types of application that you might have seen. Okay. Now what I want to do is, like you can see that the Panda allows you to read files like CSV, and once you have read it, it automatically stores different categories, different variables that are there, and then we can start using and we probably start playing with the data that we have. So after basically reading this file, which we have done, I can see what is the data that is there in that CSV file. So I can print out maybe the first 5 rows of what was there in the CSV file itself. So you can see that we have essentially a housing data where we have started from the index 0, 1, 2, 3, and 4. That's the first 4 or 5 rows. We have a price, which is essentially the house price. And then we have several other attributes and the features of the house that we have stored. So for example, what is the area of the house in square foot, how many bedrooms it has, is it located in the main room, does it have air conditioning, does it have parkings, and so on. All those attributes or features of that house is also stored in dataset. And the idea might be using the features to probably predict the price of a new house. So let's say if you have stored, maybe you can use a machine learning algorithm and we can create a regression function which allows us to take a new house for which the attributes are known. For example, it might be known that it has this much of square footage, it has this much of you know, this many bedrooms and so on. And if I know that for that, I can use my regression model that has learned from this housing data to predict what could be a possible value for that new house for which we want to, for which we are interested in. Okay, so that might be an application which we want to do. Some other important thing that that might be important for you to know is that you can use some functions like factorize to encode the object as an enumerative type, and sometimes this might be an important one. And if you want to have the representation as an enumerated type, or you want to represent that in categorical variable, then you might be using something like this factorize, right? So if I do that, if I run this block, right, it will essentially be running and displaying the same thing that we have seen above. But the important thing is that it is representing this data in categorical variable. And by using this pd.factorize command, we have been able to convert categorical columns into numerical codes that are out there. Okay. Now, once we have this data set, we can split this data set to identify what is the forecasting value variable, or what is the important regression variable, or what are the features. And here you can see that this example that I've discussed, what I can do is I can store all the features or the attributes of the house in X variable, and the price, which is the important value that I want to predict, in Y variable. And that's what we are doing here in the code block that I'm just running. So it's essentially splitting the data set that we have got out of the CSV file into feature vector and feature matrix, and into essentially the price vector that we are interested in. So now, once we have separated this, we can individually, print out and see what is stored in X and what is stored in Y. Okay. So I'm running this. Okay. As you can see, this one does not stores any of the price information that was there, but it does store all the feature values that we are interested in. For example, we're interested in the area, number of bedrooms, air conditioning, parking spots, and so on. All of those features and attributes now is stored in this X variable. Similarly, if I run this Y head, right, as you can see, now it's storing essentially all the prices, and that's the output variable, or the regression function regression variable that we are interested in predicting is stored by this Y head. Okay. Now, once you have converted this into feature vectors and Y, we can essentially take these values, and using NumPy array, we can create NumPy arrays values correspondingly. So taking this X and Y values, we can write something like this, which is X is equal to X dot values and Y equal to Y dot values, and this will take the data frame and it will convert that into a NumPy array. And if we are able to do that, then we can now start using all the different matrix operations that are there in the NumPy library, which is very, very essential for carrying out a lot of data science, machine learning type of algorithms. And those operations allows us to carry out all the algorithms that is out there. And so in this format, by doing the conversion from the data frame to NumPy array, now we can have use the power of NumPy library and essentially implement different types of machine learning algorithms that we might be interested in. So now when I'm printing the type or the shape of the X and Y, you can see that the output is that the X and Y are a NumPy array, ND array, and the shape of those, or the sizes of those arrays, are also listed as an output. With that, we have covered essentially some basic aspects of Python programming, and what I want to finish with is I want to allude to a set of cheat sheets which are listed here in the different web links that you can see in the bottom, which are related to Python's basic, NumPy, Matplotlib, and the Pandas, some of what we have discussed and covered cursorily in this lecture. But I will encourage you to go through this cheat sheet and also practice a little bit more with all of these different web links, so you can learn about Python basics, NumPy, Matplotlib, and Pandas more. Thank you for participating in Introduction to the Python lecture. I hope you have learned some useful Python programming concept from this lecture, and we will now move on to the next set of lectures, which are more focused on conceptual aspects related to matrices, which are also a prerequisite for data science and machine learning programming. Thank you.